Good afternoon. Did everyone have a good lunch? Is everyone awake? Well, first, I was told to thank our sponsors. So does anybody know or use United Technologies for anything? I know I do. Everyone probably uses them and don't even realize it. If you have a carrier system at home, that's them. If you have an Otis elevator or an Otis escalator, that's them. Without sponsors, we wouldn't be able to have the summit, and that would be a tragedy for all. So thank you, United Technologies, for sponsoring the session. I get to moderate a session that is near and dear to my heart, and it's for a lot of different reasons. One of my favorite movies of all times is The Matrix. Has everyone in the room seen The Matrix by chance?
15 times.
See, somebody else loves you too. And I look at that and I think that's data. So when Keanu Reeves saw the zeros and ones and it's like, I can't make heads or tail of that, that's what most people see when they see data. But making that data look like what it looked like when Keanu Reeves dodged the bullets, well, that's what data should be. Easy to see, easy to understand. And that makes, if you have to work to read the data, it's not really doing its job. The reason of collecting and using the data to make your job easier, not harder. So we have a great group of panelists. Each person's going to have 35 seconds to give their spiel. I'm just kidding. At any time, if you have a question, I ask that you please just stand up and I'll call on you and I'll repeat the question back to make sure we get it. But please feel free to ask questions anytime during the panel, because this is, these guys know what they're doing, and hopefully you guys at the end of the day will know what they're doing as well and what you can go back and do. So our first speaker is Andrea Curry. She is the Vice President of Project Management and Development at Shift Energy, a technology innovation company focused on leveraging shared mindsets of engineering and information technology to drastically change the way we manage energy in buildings today. Shift's multidisciplinary approach to problem solving resulted in a creation of a new approach to energy management, Intelligent Live Recommissioning, ILR. That's pretty cool. Which allows operators to unlock the previously unobtainable energy savings through real-time application of big data analytics. Andrea was instrumental to the formulation, fostering, and execution of this vision. So let's hear from Andrea.
I know. Thank you, Tommy. Thank you, everyone, for coming. Just before we start, I wanted to take a quick poll of the room and find out who we're talking to. So if everyone could just tell me if you are in the building automation services or engineering services field. Okay. How about commercial real estate? Okay. Industrial? A few folks in industrial? Okay. Earlier, I attended a session where someone asked, does anyone think big data is going to entirely solve our problem? And I didn't put my hand up. But what I wanted to share with you today is that I may not intimately understand all of your sectors, but I do think big data is going to make a big difference. It may not solve the problem entirely, but it has potential to drastically save drastically save energy over the next few years. So to that point, what you're looking at is a graph of U.S. energy consumption per unit of GDP, or energy intensity. You can see we're doing better over time, and you can see we're predicted to do even better over the coming years. But what if I told you that big data could maybe make it look something like this? You're probably thinking either she's crazy, or how could I possibly do that? So it's not really about big data entirely, but I think the combination of these three technologies are what is going to drastically change this trajectory. And some of you who were at lunch probably got a bit of an advance helping of this. So big data analytics is really about precision. I have an IT background, so I'm probably going to define it a little bit differently than the rest of the folks here. But to me, more data is better. Peter Norvig from Google has been quoted or given the recognition for saying, anyway, we don't have better algorithms than you, we just have more data. And what he's really talking about is how you can essentially use volume of data to hone algorithms. The best example, I think, is around online translation engines. So if you think maybe 5-10 years ago, I don't know if any of you used online translation engines. I was actually in a French class in 2006, and my husband is French-Canadian. I thought it'd be a good opportunity for me to learn. And I would occasionally use those engines to expedite my homework. And I would show him the results, and he would always know that I had cheated, essentially, because the results just weren't there yet. Today, my daughter is actually in French school in Canada, and I'll get an email entirely in French from her teacher. I'll put it into Google Translator, and I'll get a pretty exacting copy in English. Even the actual sayings and things, phrases, are pretty much translated into English. It's come a long way, and what's driven that is not that there are a bunch of smart people in a room frantically translating and doing a better job of building some massive algorithm around translation. It's that the volume of works, the volume of digitally available translated works has grown, and that self-honed the algorithms. And that, to me, is about the precision that big data analytics give us. The second real key thing is cloud computing. So cloud computing really just gives us limitless processing capacity. If you look at your average building controls system today, it may have about 2 MIPS of processing power. That's roughly 1/50th of a photocopier. So in terms of the processing power that we get from the cloud, it's limitless. So that allows us to run any set of algorithms in parallel en masse without the constraints that we're seeing in physical environments in the sites today. And then the third key technology enabler is really the Internet of Things. So now we've got big data analytics. We can drive some pretty darn good algorithms that we know are going to be accurate. We can run them en masse and in parallel. And the Internet of Things allows us to actuate those new, better plans back to our building sites in real time. So those 3 technologies, to me, are kind of the key for driving energy savings in our buildings. This is just kind of a laundry list of what's available in a building today. So you've got energy usage and meter data, and we've been talking a lot about that today, consumption, demand values. You've got equipment and sensor information coming from your building automation system. You've got space requirements and other even scheduling information that may be available in a site today that you may not even be thinking of as energy information. A staff schedule is very good energy information if there's no other source of a schedule. You've got weather, past, present, even future within reason. You've got utility rate information. You've got environmental impact information, and a lot more other sources. So when you look at all this information coming together, and you say, okay, well, that's great. What can I do with it? It brings us back to really what was talked about a lot in the last session over lunch, which is something we call intelligent live recommissioning. And this is really the evolution of the recommissioning track. So intelligent live recommissioning is really applying these 3 technologies: big data analytics for precision, cloud computing for power, and the Internet of Things for actuation. But let me maybe take a quick step back. I'm sure you're all more familiar than I, even, with the concepts of recommissioning and retrocommissioning. Really, they're about eliminating waste from a site and realigning with our building needs. And we're doing this periodically. We're going in and realigning with our building needs. And we found good results in a lot of cases, but we're also seeing drift over time. We're also seeing that we can't define the full gamut of scenarios that we actually need to fully optimize a building and trim out all of the waste. And from that really evolved the concept of continuous commissioning or continuous recommissioning, where we're seeing really a lot of success in small buildings, where motivated operators are taking big data analytics, are taking this insight when it's properly made available to them with the right visualization, and they're using that to manually turn knobs, essentially, in buildings, or that's my take of it anyway. So they're constantly adjusting control, and in some of our clients, we've even seen 4, 5, 6, 7, 8 times a day they're going into controls and making these constant adjustments to accommodate. And in smaller buildings, they're finding it quite effective. The trouble is, as I'm sure you're all finding, people have day jobs. They have other things on their plates that they would need to pursue, that they're mandated to pursue, and that's what they're focused on. Also, in a very large building scenario, they can't possibly recommission it and continuously the space, mentally do all the calculations and so on. So we're finding that that model doesn't scale. Intelligent live recommissioning essentially is the automation of continuous recommissioning, leveraging those three technologies: big data analytics, cloud computing, and the Internet of Things. And we found that that can drive significant savings in the building to the tune of 15 to 35%. And those savings are sticky. So we feel like that's the next step, and there probably are steps thereafter. So on that note, here's some things we're doing with Intelligent Live Recommissioning today, which is really a big data play. So, one concept is the concept of building ecosystem optimization. So today, we're working with the Vancouver Canucks, actually, on implementing this. They've got about 5,000 data points every minute. We're also getting data from other sources. It's about 5 million data points a day. And we're using that information to make intelligent decisions about how to balance energy in the building. Should we be shuttling air around the spaces? Should we be heating right now with natural gas or electricity? Should we be heating with steam or electricity? What's the impact of the lighting heat load on the ice, and how should we be adjusting in terms of the ice? And then we're not only just making a decision about that, but each minute we're writing the results of that decision back to the building and making those changes physically in controls, and we're seeing really good savings there. This is another thing we're working on actually with the Canucks and also with the University Health Network in Toronto. So the idea, I'm sure you've all conceived of this, is predictive demand management. Predictive demand management is really about being able to predict when you're going to hit a demand peak, even in a non-DR environment, just being able to avoid your peak demand charges. And we can see this coming based on historical pattern analysis with big data. And when we see it coming, we see that same set of steps repeating, then we'll store energy in the space to the maximum of our defined constraints, still within the comfort definition, and that'll allow us to shave the peak off that demand event. And then in terms of smart buildings as part of Smart Grid, or some things that could happen in the future, this is something we aren't doing yet, but just to kind of get us thinking about what is possible with big data. As buildings become intelligent, they can make intelligent decisions in real time. It enables us to become active participants in demand response, to be able to calculate the cost of participating or not participating in an event in real time, and make a decision. Even a few years from now, probably to anticipate grid needs and be a participant from that standpoint. And from there, we've got something on here about local sharing, which I actually think we'll be having an entirely different conversation 5 years from now as technologies evolve and that becomes possible. So that's what I wanted to share today. Thank you all. Look forward to your questions.
Thank you. Next up, we have Tim. Tim, do you have a presentation?
I do not have a presentation. I'm just going to use my computer's notes, so I'll put it right here.
All right. Tim Strauss is the client development manager for Schneider Electric. As a manager of client development, Tim leads the company through the process of strategic energy planning, strategic sourcing, utility bill management, energy reporting, and other data-driven energy-related services. Mr. Strauss has also been with Schneider Electric since 2012, during which he has worked with new clients in New England and Washington, D.C., including the commercial, real estate, industrial, and healthcare sectors. Before joining Schneider, Mr. Strauss was a business development manager for Enernoc for the technology-driven continuous commissioning solution serving for the commercial, real estate, institutional, and healthcare industries. In addition, he has experience in the utilities industries as well as new building commissioning and retro commissioning. Tim?
Thanks. So I apologize. I do not have a presentation to put up on the slide. I just was really thinking of speaking in a conversational piece and how Schneider Electric looks at big data and how we use it. So within the energy world of Schneider Electric, we look at the world through what we call the energy management life cycle, because everything starts and ends with a real strategic plan around energy, and it's a circular cycle. We start with strategic energy planning, and then we look at the world through procurement, and then we look at the world through how we control buildings and how we optimize buildings, and then how we measure and verify everything that happens within the energy efficiency world. And all those pieces of the energy management life cycle depend on big data solutions from our standpoint. So I thought I'd talk about the supply piece, then the demand piece, and then maybe how we integrate the data, and then how we would measure and verify that data. So from a strategic energy planning and the supply piece, we are constantly mining data at all levels. And the challenge continues to be for us, and I think for any company, is to make sure that that data is accurate, it's clear, it's auditable, and it's actionable. And I think that, Andrea had mentioned, she didn't raise her hand. I don't believe that, and I don't think our company believes that the solution is big data and big data alone. There's always going to be a human interface no matter where you sit on the energy management life cycle in regards to managing those data solutions. And, but from a supply standpoint, we rely on big utility bill management systems. We rely on data on figuring out what the real-time pricing is going to be, on how to best consult our clients on how to buy their energy and who to buy it from and when to buy it. We are constantly mining that data to understand what real-time pricing is at all points. So from a supply piece, big data is always used, but at the same time, it's always analyzed from a human eye in order to make sense of that data. Moving down to the demand piece, I just from our standpoint, we look at it a number of different ways. You've got near real-time data, you've got invoice data, you've got near real-time data, and you've got utility data, which is near real-time, pulled by an EPO. So all those things start to lend themselves into further on down the wheel in regards to optimizing your buildings. So at Schneider, we employ a number of different optimization programs using near real-time invoice data, whatever it is, and always against the backdrop of driving down energy efficiency costs or driving operational efficiency through whether it be a continuous commissioning solution or a retro commissioning solution, or even providing energy strategies in the optimization pieces. Thanks. From an integration standpoint, it's not always easy. It's always easier said than done to integrate the data from a building management system to a third-party vendor. So from a data piece, we provide an open protocol system, whether it be BACnet, LawnWorks, Modbus, and it needs to be a system that software integration no longer becomes an obstacle in order to start putting these third-party systems onto your to building to provide energy efficiency. Maybe 5 years ago, 6 years ago, we would try to automate, we would try to pull data from the building management system, integrate it with the building meter data to create that one platform. But with the old legacy systems, if they were proprietary, you really couldn't pull the data unless you were going to maybe spend $50,000, $60,000 to a software upgrade. It became cost prohibitive to do that. That seems to have all disappeared in the past 5 years, where most systems now are an open protocol system, Niagara-based or Tritium-based, where you should be able to employ a third-party system, whether it be Schneider, whether it be Building IQ, whether it be Clockworks, whether it be Enernoc even, to be able to pull that data and now start to drive energy efficiency savings, which drives down to the bottom line, which is from the commercial real estate world, for the most of the part, that is the driving force that needs to happen. From an analytics standpoint, analytics now is it's no longer looking at just energy savings. It's more focused on operational efficiency, default detection. So all those systems are out there now using big data with, again, without relying solely on the data. Every piece is still looked at from a human eye standpoint to make sense of it, because you may see something that's going on in the building, but it's there for a reason. And to just arbitrarily start to say, listen, we recommend these changes or these energy efficiency measures may not work. It may not be the right reason to do so. So everything has to be looked at from a human eye standpoint. Moving down the line, the big data also has to be reported on effectively. So from my standpoint, we use what we call our structure-aware platform, and that can be at the facility level, the operational level, or the enterprise level. From my standpoint, it's mostly the enterprise level where we use Resource Advisor, where all of that data is brought into one, let's say, warehouse of data points, and then you can report on that, whether that be Energy Star reporting back and forth to Portfolio Manager, which is now hot and heavy, whether it be CDP reporting in the sustainability world or GRESB reporting. That has to be all auditable data that is real, it's clear, and it's not an overload. So again, the theme from my standpoint is relying solely on the big data piece is a big piece of it, but it always has to be combed through from an energy engineer or what have you, a real human, live being that has to comb through that data to make sure that it's being properly used. Thank you.
Thank you, Tim. Next up, we have Kelly Millsap. He's the Chief Technology Officer for Related Companies. Kelly is the Chief Technology Officer for Related Companies, where he is responsible for the technologically strategy for the Hudson Yards Development Project. Mr. Millsap has had technology leadership roles on development projects, including the Cosmopolitan of Las Vegas, Snowmass Space Village, and the MIMA, among others. Tim? I'm sorry, Kelly.
Thank you. Thank you very much, Tommy. I know we've had a number of different discussion topics today that really focused on big data and some of the challenges around implementing big data. I know many of you, how many of you who are working on getting to data-driven decision-making have ever had any challenges with data integration? Yeah, okay, great. How about reporting or presenting something back in a UI? Great. I'm not going to talk about any of that stuff. I'm going to assume that we're going to cover that in several other areas. What I'm really going to focus on is something that we call actionable intelligence, which is basically in premise, the idea is trying to get to an improved signal-to-noise ratio. Our belief is that if we don't use the data to in some way transform our behavior or take a different action, then in fact it hasn't served a very useful purpose. And that really goes to the core of that signal-to-noise ratio. So I've only got one slide, so I'm really just going to walk you through some of our process around this. Specifically, it's very important when you start really trying to get to the point of getting good signal-to-noise ratios in your data analytics that you understand what your objective is. At a very high level, ours is to optimize building and resource efficiency and maximize our comfort for our tenants, our users, and guests. With that in mind, there are a lot of different attributes that you may want to define when you start looking at this kind of a goal. So when I look at something like resource efficiency, I might want to put together some metrics around how much energy was consumed over a period. I might then need to create context around that data, which is, in many cases, what was the external temperature, what was the occupancy level, particularly if it's in retail or something, we've got a lot of variability in terms of the occupant structure. But all of those kinds of things really help you define the detail and associate with what your objective is. And obviously, it really helps to begin with the end in mind. So that's the first step that we've gone through. The second thing is to align business value. I think in many cases when we sit down with our decision makers, the trees get lost for the forest to some degree with the idea of big data. What we really try to do, I know there are a number of developers in the room. You certainly likely already do some kind of customer segmentation around something like commercial, residential, retail, et cetera. That certainly is very relevant here when you look at energy profiles and footprints. But there's another aspect that we really had to bring to bear in terms of our segmentation in this context. And that was getting into the perspective of we have a lot of legacy assets in our portfolio that really have mechanical equipment, thermostats, other control equipment that is completely decentralized, doesn't take any historical representation of its data, and it really isn't a very short-term path for collecting and then aggregating all the data in terms of the building performance. So that's one way we would classify the data. In the middle of our spectrum, we really have what I will describe as more recent assets that have a building management system, that have some level of historical data recording and have data aggregation through that building management system. All the way to, I'll describe it as sort of our next generation or maximally capable systems where we might have cogeneration, demand response, triggers that really try to optimize which sources of energy we use on a given day and a given moment based on the pricing of those resources at a given time and our loads that we have on the properties at a given time. So there's really a very broad spectrum of things that you can consider in terms of classifying your portfolio, and each of those becomes very relevant in terms of the gap between where those assets are now and where you want to take them when we go back to our goal, which is really building a resource efficiency. The next is really to define success with baselines. When I talked a little bit about some of the assets that don't have any historical data, it's very, very difficult to get very granular about what success and failure means if you have no context for that. You can certainly look at your overall utility bills and things of that nature to create some perspective where you've had an asset for a period of time. Or you can get much more specific about particular assets on that other end of the spectrum where we might say we want to match our energy source with the lowest rate in the market within a one-day period, or there's a day-ahead pricing and some other considerations based on spot markets on energy consumption. So there are a variety of things that you can do to establish what those baselines are, but it's incredibly important that you define that line where success exists before you get on set with your data analytics project. The next is to prioritize time to value. When you start looking at big data holistically, and certainly when you put it in terms of energy use and building intelligence, it can be like trying to boil the ocean. You're trying to move something that's very, very large. What we really tried to focus on when we looked at our portfolio classification are where we could get the quickest time to value, because maybe we had a particular asset that relative to its comparables was underperforming based on its energy consumption and price or cost characteristics in our management strategy. Or perhaps we had to have 2x the number of engineering resources on the property because we had really reactive mechanical equipment situations. But whatever those things are, we really tried to prioritize where we were going to invest first so that we got quicker time to value and could really prove to the business that we had some material success and impact on the business through those activities. The next is that the low-hanging fruit may not depend on new technology. I can tell you one of the exercises our engineering team went through was to sit down and define a series of what I'll refer to as sort of use cases around business logic. If this, then do that. Whether we're talking about systems that have different kinds of BMS head ends, Siemens, JCI, there are different protocols that may exist in different kinds of BMS systems throughout our portfolio. That activity is incredibly important when you start trying to codify that into the automation of your response characteristics when you have certain events and triggers in your business. But you don't have to wait to deploy a system to use that kind of information. And our engineering team has wisely started working with their rule set and claiming value that's material even prior to us deploying any kind of big data. I'll call this little data. Right, it's more collaboration system, existing tool driven, and process centric. But we're able to extract material value in that context as well. The next lesson learned, I think, that we've had as we're going through this process is that you really have to celebrate failure. And I obviously don't mean give a promotion to a guy who does something incredibly irresponsible. What I really mean is you've really got to institute in your business a culture where individuals who bring problems to light, that there's not sort of a witch hunt to find who's responsible for something, but rather a witch hunt to figure out how we solve the problem, right? There's an issue and we want to optimize behavior. And that really, I think if you get into private equity and other kinds of businesses, there's a context around quick kills. I make an investment, it's not working. I want to shut that investment down very quickly. There's something very similar you need to do in this context, which is not every idea you pursue in your data-driven decision-making process will be effective. Don't hesitate from a cultural perspective to acknowledge that fact. You're on a journey and you haven't arrived to something that's highly mature yet. When those things don't work, don't hold people accountable in a negative way. Rather, quickly stop making bad investments, iterate the process, and focus on the things that do work. And then lastly is establish a regular rhythm to measure outcomes. It's great if you set up these baselines. These processes, for us, we're in flight in a couple of parallel streams in these. They take years. It is not something that happens. I left out all those challenges around data integration, reporting structures, UATs, with your user base. Those things are all very time-consuming. Just getting consensus on what to do in certain situations from a business strategy perspective can be time-consuming. Don't lose sight of sitting back down with the business and saying, hey, this is what we thought we were going to achieve. These are how we define success. These are the criteria. What have we actually done in a regular rhythm? In some cases, the success criteria is really over a span of years. In some cases, that it may be nearly immediate, depending on what we call them KPIs, key performance indicators, depending on what that is. The time component of that will change. But what's very important is that even if a process takes 12 months to implement, we're still meeting very regularly and no less than quarterly to sit down and say what's working and what's not working. But I hope that gives you a little bit of insight in terms of how we at least are approaching big data and trying to make it much more tactical. And again, we like to refer to it as actionable in terms of actionable intelligence. So thank you.
Thanks, Terry. Next up, we have Mike Rogers. Mike currently serves as the Shared Services Operations Manager for Sodexo, servicing the International Monetary Fund account, which is a 2.8 million square foot building here in Washington, D.C. His current role is Michael is responsible for the leadership of the safety administration, energy management, compliance, quality control, strategic sourcing, sustainability activities that support the IMF in their approximately 2.8 million square feet of headquarters facilities. He has a bachelor's in technical management, over 18 years of experience in facilities operations and energy management. He and his team have been recognized as innovative leaders in energy and big data analysis. And he actually is going to use his computer in a couple minutes to show you some real time. Yeah. And if you haven't seen that facility, it's ginormous.
Thank you. Okay. Well, I'm not going to spend a lot of time talking about some of the topics we've reviewed a little bit earlier here on big data systems. I'm going to talk a little bit more later about how we as an organization bring in the people element of this into collaborating with all this information. As you know, there are lots of data sources out there, from the building automation to financials to setups of, we do a lot of meetings, so we need to monitor this information, as well as utility analytics. So to bring all this together, it can be kind of daunting. I'm probably known as a data hoarder, collecting a lot of information. Sometimes the valuable information can be hidden in all the massive data. There's a lot of tools out there to help us, but what we've used, and I'm going to try to do a demo of some specifics how we've used this in a business case. We were bringing in our energy information, our weather information, even our equipment maintenance history, as well as environmental comfort and our client experience, as well as our building engineering information to make sound management decisions. I kind of like this slide. I'm sorry if it looks a little rough, but it talks more about how people collaborate, because we've all probably heard of the example of the broken telephone, right? When information has to come through layers of building system through our engineering and management up to the owner, sometimes the message can get lost. What we've tried to really utilize is the collaboration, and within the data warehouse, everybody be able to look at the same data and ask questions from different perspectives. I guess you may call that the wiki approach to looking at data, but it's really about creating an environment where we can ask the correct why questions, and we'll talk about a business case example. Okay, understand the data. In the data warehouse we set up, we first of all, you have to make friends with your IT department. You really have to work together to come up with a feasible solution, because we talk different industry languages. In my own history, I've worked in most of these fields, including IT, building automation, engineering, and then management. So it helps to be able to develop that communication and understanding amongst each other. But you really, obviously, we need to assess what kind of data we need. What is the volume going to be generated? Is our IT infrastructure able to handle that many records? And how are we going to handle network security? Very big issue where we work is, how are we going to secure this? I would love to be able to connect through a Citrix and do a demo today, but that I think we won't try that today. I think we'll have some time limitations with that as well. And asking, what information is going to be valuable for us. This is a case that we're going to try to hook up here and do a little bit of demo of, but really generated some great projects using this data warehousing concept, not only technologically, but as with our engineering staff to really ask some questions to understand what the energy demand patterns were, what the operational performance was, and even tying in our CMMS system to be able to kind of look at the work history and how that's related. Another data element that we can compare is our environmental comfort. What do the hot and cold calls look like that are coming in? Okay, and again, what we've seen from this is greater efficiency and streamlining some of our processes. So with that, we're going to try to see if this is work here. Okay. Well, a little different resolution, but we're going to give this a shot. Okay. How many are familiar with pivot tables, pivot forms? Pretty good, right? Everybody's pretty much gotten familiar with them. Instead of trying to wirelessly connect with our data warehouse, what I've put together is kind of a simulator, if you will, of the data warehousing concept and how, again, building management, engineering staff can get together and pull data into a pivot form and start asking questions. Does this make sense? So my first question, and I'll try to talk in the mic, maybe I can move it just a hair, is how is our building performing as far as the temperatures inside? Okay, I'll explain the axis. The vertical axis, the y-axis is temperature, and the bottom axis is the time. So we can see overnight it got pretty warm. It got 77. That's not terrible in the summertime. We can see about 4 or 5 o'clock. It looked like probably they started up a chiller, right? Brought the temperatures down to a very reasonable range, around 73 degrees. Okay, so to kind of back up my assumptions about it was a hot day, I'm going to pull in outside temperature and see, yeah, indeed, it got pretty warm that day in the afternoon. In fact, it got up to almost 90 degrees, 89 degrees. So how did my chiller plant perform? Chiller consumes a large portion of our energy, so it's an opportunity. Okay, pardon the rescaling, it does automatically. But we can see startup happened around 4 in the morning. It looks like they wanted to be proactive and get the chiller started. And they did a good job of maintaining temperature. I can see that. Even when the temperature went up in the afternoon, we can see the chiller ramped up. And what I kind of liked about this is, I kid with them when I see patterns of spikes. They know what I'm asking. I'm always trying to work with them to curtail the spikes and make sure our systems are operating properly. So with this information, my last question was, is there any other opportunity to shave off some of this startup time? So ideally, you have occupancy sensors to tell you all this, but one tool we have is we meter all our floors. We know the plug load and the lighting. So it's a pretty good indicator to me when people are actually getting in, turning on their computers, turning on their lights. So we can see the morning startup in the morning. Pretty close to the time they're starting their chillers, they're like lighting schedules coming on automatically. But that's just a base load. It doesn't really, until about 9 o'clock, do we see a lot of occupancy. And that's just the type of business they have there. They're working with countries all over the world, so they tend to work later, come in later sometimes. So we saw here was an opportunity to start adjusting our schedule. So this is one tool. There's a number of different data sources. I don't think we'll have time for that today, but that's a demonstration.
Thank you very much, Mike. So we'll open it up to any questions. Does anybody out there have questions first? Yes.
How do you value the data, the results, and how do you charge for it? And I'll give you just kind of this perspective. Recommissioning a building, sure, we're going to go in and we're going to find inefficiencies. We're going to wring those out. We can identify the value of changing set points and optimizing the system. And you as the buyer would say, sounds great, I'll pay you for that. Now that we're going forward and we're live commissioning, monitoring all the time, what's the value of, am I paying you as an insurance policy? And what is the value? Have you come across that as a kind of a tough selling point? Because I certainly have.
So the question is, how do you value the data, and then how do you pay for the data? Is that the question?
The monitoring service.
The monitoring services of the data. Anybody want to start on that one?
Sure. There's a number of different ways you can do it. Number of different ways you can do it. I think for a little while, people started to get into the shared savings program to say, the amount of savings that you're going to get, we'll take some of that, but that typically ends up in a strained relationship between the vendor and the end user. So we've seen a monthly fee for service, whether that be based on savings, whether that be based on energy spend. Typically, people might be see that as a way to do it, but it's a monthly fee for service because you can put a value on the drift that will happen again if, in fact, you don't persistently keep your building tight through some sort of continuous commissioning program, has been my experience.
In terms of Intelligent Live recommissioning, what we've found so far really is that we have to have a really clear sense of the value up front. We've talked about it. You can't. The solution I talked about is not a plug and play. I mean, I wouldn't kid you to think there's a device you could drop in and then without an engineering effort, turn this thing up and it magnificently just trims off energy savings. There's obviously a big assessment that happens up front, and the implementation of the software is almost equivalent to a one-time retro commissioning exercise in terms of what it looks like in the various phases and so on. So you've got to have a really clear idea of what the value is going to be up front, and then I think with any new technology in this phase, you've got to be willing to stand behind the savings and put some skin in the game. And that's what we're seeing with our customers. And we're actually seeing various, we're an enterprise software company, so we tend to go to license fee structure, like an upfront one-time license fee, which for some of our customers seems to map up to how they want to spend their capital budgets in terms of the competing priorities that they have. And other customers are looking more at a shared, more service model as well. It's just depending on how the money falls.
So from my perspective, it also depends on how it was paid for. If it was CapEx throughout the building, everyone shares it back through the OpEx. And if you can lower the OpEx, at the end of the day, you're paying $50 a square foot. You're still paying your common area maintenance costs. If I can reduce that back down, maybe it goes back to a CapEx cost. When it comes down to individual floor units, well, I think that becomes different. But when you really start thinking about how you normalize data, if a building has 5,000 data points, which is probably a building built 5 years ago, you're still collecting 840,000 a day that you have to then normalize. Our newest building has 78,000 data points. So if you do the math, it's over 4 million a day that we have to normalize to make sense of. And when you make sense of it, everyone benefits because the building itself as a whole runs more efficiently. So yes, you're paying a percentage of it, and at some point, well, if client Y decides he's going to put a more efficient server or HVAC system in it, he's going to benefit it because it's directly billed back to him as well. I saw some more questions. Does that give you a...
Yeah, I agree with all the arguments. I'm just saying it's I have had a hard time presenting that because if the real-time commissioning works and you never effectively
Well, that's a good engineer.
Is
I mean, that's a good engineer because, you know, I've managed 60, 70 different office buildings from the first LEED Platinum one in Washington, D.C. to one that had time clocks. And I don't care how good or how bad they are, they're going to drift. I mean, it's going to happen. But being able to catch it, recover, and fix it, you know, again, if it's common area, well, it's CapEx. Everyone benefits from that result. But at the end of the day, you know,
We build into our product as well, just to kind of add to that, a comparison or a savings counter from baseline. So it's the same IPMVP
Yeah.
process you would normally go through, and we essentially build that model into our software, and then we track the savings by energy source over time
that's
in the software as well. So we can alarm and alert on it, so we can see if it does start to drift and address that issue.
we do the same as well. The question was, how do you establish the baseline? I'll start at that one. Well, that's the MEPs that design the building should give you a baseline. And my goal as a CIO for building new buildings is to always beat that baseline. So when you design a building in today's technology, they can give you a pretty darn close estimate to what that cost for utilities are going to be. The baseline is by day, by month. Well,
Yes.
it's yes. I mean, you get it. BIM will model the building in anywhere you want. So the answer is yes. You have to ask for it, but you need to get it from your MEPs that design your building.
Typically, we're going into buildings that are at least a year live, so
Right.
we can get a year's historical data,
Right.
and we'll baseline based on that historical billing information,
Yep.
Right.
and the impacts of weather and all those.
Yeah, occupancy and weather would play a big part of that as well.
Production.
Yeah.
Weather's a big part. I mean,
Yeah. And our-
weather and occupancy really,
Yeah.
the two biggest factors. You know, you look at a building and, oh my God, it saved 30% of the energy. Well, the occupancy dropped by 70%. Well, you better save 70%.
Right. Not necessarily, though, right at the end
True,
of the
because
day.
you still got to run core factors.
Yeah, right, yep.
Yeah, no, I'd say we tend to baseline in year 2 of operations, simply because you're loading the building with the tenants and a variety of other considerations, and systems are coming online, but you don't really hit sort of steady state, you know, obviously just when the building comes on, and although some models are very accurate, some are less so. So we tend to baseline after or in second year of operations.
And that's a great point, because we in one of our buildings, we baselined it after the first year, couldn't figure out why we were so far off. Well, we were so far off because the first year was all construction, so there was no inhabitants to the building. Once we get to the normalization at 18 months of the building be completed, we realized exactly where we were and dropped from there. So that's a very big point of it. I mean, you got to make sure that you don't have guys running core drills all day long and the HVAC is running to make sure the systems work. Yes.
My question is following up on the live recommission. Is it a data-driven strategy or an algorithmic strategy?
Could you repeat that one more time? The data that's collected, is an algorithm or is it data?
Is it driven by data?
I'd say it's a combination of the
Yeah.
two. So there's a set of core algorithms, and the algorithms respond to the volume of data and self-hone over time. But if I had to pick, I'd say it's algorithmically driven. It's really an engineering exercise up front. And then essentially there's a learning period where we deploy it, and those algorithms will hone over that learning period based on data.
So you saw the chart that Mike put
I
up
hope
there?
that helps.
Yeah, so you saw the chart that Mike put up that showed that the building wasn't really occupied until 9 o'clock, but if they didn't bring the chiller on at whatever time it was, 4 o'clock, they could never make that. That's an algorithm. That's going to tell you that I know how long it takes the building to get from X to Y and put that together. But the downside slope of that, and a lot of that, is more analytics. Because now you're saying, okay, at lunchtime, 75% of the people in your office leave. Your O2 levels drop by 75%. We should stop the outside air. That's going to be analytical to say, okay, stop bringing in 100% humidity on a 100% humidity day and let the building coast for a while.
Given the example that was presented, I don't think that is enough information there to make that conclusion. There could be a specific weather or an occupancy
Absolutely.
requirement that they direct.
Right, he didn't show O2, he didn't show any other factors that make those up.
It is context-based. And what I'm saying is that when you have a live recommissioning that drives based on just a set of data, there is external factors that are not always there.
Absolutely.
That was the reason to drive behind it. Maybe we had a trivial case on the example, but there are other situations where this is a lot more critical when it comes to chiller startup time, for example.
Absolutely, and that's why it's really important when you're rolling this kind of system out that it's not sort of a, here's your system, go ahead. That it's a process that you're making sure you're seeing it through the conditions and that you're able to adjust. So the algorithms include calculations that pull in those data values into the calculations, right? So weather would be one of them. And you've got to monitor the system live through those seasons and make sure it's adjusting accordingly to your example.
I would just add too, you also need to look at other data sources like hot and cold calls, people feedback, those other indicators. So that's one of the approaches we've tried to use we don't always see it in the numbers. Sometimes it's hard to see through the matrix.
Believe me, we all see that one.
I would add, things happen for a reason, so that I would always continue to contend that you can't depend on the data solution on its own, no matter how many points of data that you ever have. There's always, in my view, you have to have somebody that's a real live person looking at that and understanding why things are happening and having an understanding of what's going on in that building, because the buildings are changing all the time.
That is the absolute 100% the most real thing there is. We just went through a retro commissioning where we retro commissioned a building, did physical inspection of the entire building, couldn't figure out why we had a rogue unit. Well, if we didn't have eyes, realizing that someone had cut the controls to a VAV that had static pressure all the time, and they realized that, so they cut the static pressure sensor, wired it together. It's calling for error. Our systems were running. If we wouldn't have had guys on the ground walking, looking for that, our system said there was nothing was going on. But in reality, the systems were running. Which is horrible, but but we had to catch it. We did catch it. Yes.
You mentioned the sampling rate. Might have
Yes.
15 minutes or so. Is that a fixed? How do you arrive at that? It's a fixed sampling rate. Do you adjust it?
Well, that's a good question, and there was a lot of debate.
So let me repeat the question. How are you getting to the time that your data is collected? Is it 15-minute, 1 minute, 5 minute, 1 hour increments?
Well, yeah, that was actually in one of the slides, as you mentioned. And there's a couple things we need to look at. Is it practical to gather 15-minute data of everything? There's a cost to gathering data, which you need to consider. And our discussion with our IT group and engineering group is what is the lowest resolution that we need really to get valuable information. Obviously, in a morning startup, I need at least hourly, if not 15-minute interval, and there's a value in that data. So I hope that helps answer the question. Other information like weather, it's good to have 15-minute, but maybe not essential. A lot of times we just use degree days, which can be looked at daily.
I also think it depends on the data type, because if you're looking for peak load, that's the instantaneous flash. If you're catching it every 15 minutes, you're not going to get your peak demand load from your utility, and then you may not be able to go back and find where that demand came from. So it depends on which piece of data you're trying to collect. If it's temperatures in offices, maybe every hour does work. But if it's actual electrical consumption, you want that as real time as possible.
And just to add to
Is that fixed then or variable depending on the nature of the phenomenon?
My thought on that would be it depends on the source. It depends on what we're looking to get it from. Until you define what you're looking for, you don't know what to give it. So again, if I want to know when my demand load came from the building, so whether it's a chiller that's starting up hard or something like that, and I only have every 15-minute increments, I'm never going to capture that data because I'm getting an average of the 15 minutes. I'm not going to see that start up or stop. But if it's occupancy, well, 10 or 15 minutes doesn't really hurt you because you're not going to have 1,000 people leave the building in a 15-minute period unless you pull the fire alarm. So, it really depends on which source you're looking for. And that's defined when you define the processes that you're going to do. So I know in lighting, we're going to do X. I know in HVAC, we're going to do Y. So I think it really depends on the data source.
Our approach is a little different given that we're more of an enterprise software company. We shoot for a minute resolution because that's the common resolution that enables all of our strategies. In some cases, though, we are limited by the capacity of controls. our physical integration with controls, poles, controls infrastructure, and if you've got a 20-year-old control system, then we may
You're not gonna
pull
get
it to
yeah.
a stall. Within our technical constraints, we pull as often as a minute if possible.
Very good. All the way in the back. Forever. How long do you recommend keeping the data? Back, I think someone was talking about it earlier, when the USB stick was, 128 meg and it cost you $5. Well, now for that same $5, you can go out and get a 16 gig that looks like a Mickey Mouse or a dinosaur or whatever. In today's cost of data, if it's not costing anything, save it. You can get a gigabyte storage from Amazon for $1 a month. That's a lot of data points. But I think realistically, it depends on what business you're in. If you're in some businesses, you got to purge it every 7 years. It's not your choice. It's going to be depending on who it is. But from my opinion, I can tell you, I've been with my company for 17 years. I can go back 17 years from the first system I put in. I can pull that data up today.
And there's value in that data. I mean,
Absolutely.
People come to us and say, listen, can you historically upload data? And what do you recommend? It's like, well, what do you have? I mean, if you've only got 2 years, that should be enough. But if you've got 5 years of data, then you can actually set trends off of that data right from the get-go. So the more data you have, the longer you have it, the more valuable it is.
Perfect example is a building. We sold a building in 2003. We ended up reacquiring that building in 2007. The people that had managed it for those 4 years didn't collect anything. So when we took the project over, we had that data pre-2003 to compare it to where it was. And if we wouldn't have stored that data, we wouldn't have had it. We'd have to start over from scratch.
I think the question really becomes as well, how long do you keep it online, right? How long do you keep it online?
Yeah, that's probably better.
Versus how do you, when do you archive it off? You'd never probably delete it, but you probably want to keep it online long enough for you to be able to effectively enable decision making, which is typically a year to 3 years.
3 years.
Yeah.
Question over here in the back. Sorry, I can't hear you.
No, we don't replace really any part of traditional controls. We layer on top. We do have fault detection diagnostics from one standpoint, but it's the net new analytics that we can add from energy information for the most part. So I can see the coefficient of performance on this piece of equipment has degraded over time. There's likely an issue will alarm. So we integrate those kinds of value add things. If there's already a fault detection system in place, though, we try to augment that fault detection system.
I was just going to say fault detection's great, but I don't think systems like yours, you don't want to over alert, right? You just want to you want to create decision making you want to create decision making on actionable pieces of data, maybe on a monthly basis, depending on what you're trying to do. But if you could be over alerted, and it just becomes at that point prohibitive.
So, also to your point, just one more thing is. So, for example, if we see, there was an example someone gave this morning where you could see a line item and it was damper position or damper stuck, and someone had to go out and service that. If we see a valve is stuck, we'll do what an operator would do: open, close it, open, close it. If that didn't work, we may alert on it. But the first thing we'll do is open, close it in an automated fashion. Hopefully, make it go away.
Very good. So our last question. So how do you manage data quality?
Go ahead. Yeah.
I mean, from our perspective, it's a significant struggle. I think a lot of people have talked about data normalization, but it's really not a trivial exercise. And I think in a variety of different ways, we had to go back and look at how we were iterating the systems. We often do analytics where we're trying to add another variable and correlate that to some event in the source system. So we built something we call a master data model to correlate where we input and insert changes, and then we normalize the data based on standard units and other components. But it's a very active pursuit.
We do it through preventive and corrective maintenance. So all of our corrective and preventive maintenance ties back into it as well. So if we're getting readings of 15 CFM or what, and you go do a PM or a CM and they don't match, it alarms us. I mean, that's the best way we can do it. And it really, sometimes it's enlightening because you'll find out that a sensor is off by just 1 or 2%, but yet it's that 1 or 2% really hurts you.
Yeah, it's actually part of our ongoing commissioning program too, that we've documented what is going to be the calibration frequency of different devices. And that, of course, ties in with your preventative maintenance plan to stay on top of that. But that's all part of our lead submission.
Yep. Very good. I'd like to thank all the panelists and thank everyone for attending the summit. Hope you had a good time and you learned something.